year. Okay, so again, as I said, again, the midterm will be 4 chapters. Again, this is our textbook. I posted this textbook in the Blackboard, so everybody have a copy. Those of you bought the from the publisher, that's fine. It's the same chapters. This is I think this is the 10th edition. By 11th, 12th edition, the chapters are the same, the materials are the same. So as we said again, the midterm will be chapter 0, 1, 2, and 3. Everything. So we should know what is a set, what is a real numbers, the rules, for example, what is a natural number, etc. Integrate exponents, those are also the properties of exponents. Like if I have two, I'll say if I have two terms, and they have two variables with exponents, and the two terms are the same base, and they are multiplying, then I will add their exponent. If I have 2 or more terms, and the base are the same, and we are doing division or anything, again, the rule said that if it's division, we subtract the numerator from the denominator. If it's multiplication, we add the 2 or more, or the exponent together, as far as the base are the same. We also talk if we have a term raised to a power and raised to another power, then we are going to multiply all the exponents. If an exponent raised to another exponent, we multiply all the exponents. And also we said that any variable or a value raised to the power 0 is always 1. We also cover the radicals and also rational exponent. Maybe we'll go through the textbook, see one example very quick on it before we start chapter 4, if there's enough time. So in chapter 1, again, linear equations and functions, how to solve a simple linear equation, system of linear equations, also inequality in one variables. Graphing and also graphing utilities, I will not cover that because again, we don't have the materials, and also we are not going to use a scientific calculator for the exam, so I'll skip that. So, but you should know how to apply functions or linear function concept to solve business and also economics problems. So we may see some problems whereby the model is given to it. For example, if we are solving business questions, most of the time we'll be concerning with the revenue that the company, the business organization will generate. We're also going to concern about the costs, and also it depends. We have 2 types of costs, the fixed costs and the variable costs. We should know the difference between the two. And also the profit, of course. So for example, equation will be given to represent, or a model will be given to represent a cost and a revenue. And they may say find the profit of the model, or find the profit. So we know profit always is the revenue minus the total cost, etc. So we may see a question like that. The same thing applies to quadratic equation. We also have a business questions, business applications using quadratic. We should also know how to find quadratic equations. For example, why the quadratic graph will open upward or downward. And if you open upward or downward, what will be the vectors? Is the vectors value will be maximum or minimum? So we went through how to find the vectors of a quadratic functions. And also that moves us to the last chapter for the midterm, which is chapter 3. We learn about matrices. So first of all, we should, again, now we are not going to ask a question, for example, what is a matrix? Or what is the name of the values in the matrix, etc., or what is the transpose of matrix? No, there will be no theory question. This is mathematics class. So first, for example, the first thing we should know is how to add and subtract matrices. What are the rules behind it? When can we add 2 or more matrices or subtract? We also should know how to multiply a scalar value with a matrix. A scalar value means a single unit of a value, let's say 1, 20, any value multiplied to a matrix. We should also know how we can multiply 2 vectors together. A vectors means the matrix have only one column or one row. How do we do it? Then when it has more than one or two columns or more than one rows, then it becomes matrix. So we should know how to do the multiplication of matrix any size. Then the Gauss-Jordan elimination, as we said earlier, the process is a long process, time consuming, but you should understand the concept. So we may give a partial solution already. So when we give a partial solution, you have to finish it. Also, you should know how to find the inverse of a matrix. In this case, a square matrix. Normally, inverse, to find or first of all, we say, okay, what is an identity matrix? Identity matrix always have to be square first. Then the diagonal, the values will be 1, 1, then the rest of the values will be 0. Most of the time, when we're looking for inverse of a matrix, most likely that matrix have to be a square matrix. A square matrix means, again, the number of rows and columns are the same. And we didn't cover 3-5, so I will hold on to that, and it will not be on the test. And we did up to 3.4. Since the midterm is only one day from now, Wednesday, today is Monday, I don't want to give a new topic today, or even if we cover any new topic today, which I want to jump to chapter 4.1, it will not be in the midterm exam. So we can look at some questions in the textbook, or if you have any. Again, I'm very flexible here. The review is not for me. The review is for the class. So if you have any question between chapter 0 to 3, or any homework question you think we should explain to clear things up, you can let me know. Otherwise, I will just randomly pick any questions. We don't have enough time to cover all the materials in one section. So I will just randomly pick any question I think is more interesting and not that easy. So for example, I'm going to skip the set questions because I know those questions are very straightforward. Unless if you have any question, I'll stop. We can look at the question.
I had a question about the homework.
What chapter?
Like the last chapter, like the last homework. 3.1, I think.
Okay, 1 second. Let's go there. That would be week 8, I think. Okay, so we just open. Actually, I didn't open the week 9 yet. We will see week 9 soon. So again, that's a week 8. Which section? Which one?
It was from the homework.
Okay, the homework. Which number?
3.1.
Okay, the first one. Okay, let's see. Again, any question you want, we can answer, but I think this page, we have only 2 questions. Again, we're solving only the questions that is circle. So which question you have question with, please?
With the number 19, I didn't understand what the T really means.
Okay, question number 19, they say you should find A plus AT. The T means a transpose. So a transpose means if you have a matrix A, and they say we should find matrix A plus matrix AT. Again, the T means A transpose. It means you are going to convert the rows to columns. So let's see. Again, I don't want to solve the question straight if you haven't submitted it. But again, I'm going to give the same example here. Just give me 1 second. I'll get the slides out. We have example there. I think that should be 3.1 if I'm not mistaken. Let's see. Again, we still have students that didn't submit the homework yet, so I don't want to solve it, but I'm just going to explain it with one example, which is here. If it's not here, then I'll just do it, make it. Okay, so this is a good one. You see, for example, here we have a matrix A. This is matrix A. So let's assume this is the homework question. Now, they say you should find A plus A transpose, which means you are going to convert A to A transpose. You find the transpose of A. So here we have 137 as a column. It becomes 137 as a row. 048 as a column becomes 048 as a row. 323 as a column becomes 323 as a row. So the third column will be third row. The second column will be second row. The first column will be first row. Then you add that to this, then you get the answer. You understand me?
Yes.
Yeah, so for example, let's say the matrix will be 3 by 3 because if I change all the columns here to row, it will be the same size. All the columns here to row again, the same size. So then you add each element, that's it. Any other question or any student? Okay, so I'm going to close this if no question on 3.1. Okay, so I will continue with what I'm doing now. Again, as I said earlier, I'm going to skip all the set questions because they are very straightforward, unless if you have a question. The second is there. Okay, I'll skip the real numbers also. We should know real numbers, maybe 2 is less than 10, -5 is greater than -50, etc. So this is basically the numbers. Also, we should know what is a natural number, what is a real number. And also the integral exponent, again, I think that's actually everything is here. So if I have, let's see if we can zoom this a little bit. Yeah. So in this chapter, this is what we need to know, the properties. So if I have two terms and the base are the same and they have exponent, I'm just going to add the exponent. Now, if the base are not the same, you can't add the exponent. You cannot. And now, if you are doing division, as far as the denominator is not 0, if we have the base for the numerator, the base for the denominator, if they are the same, then we are going to subtract the numerator, the denominator, the down, we are going to subtract the n from m, which is here. Now, if m is the same as n, then we get 1 because 3 minus 3 is 0, a raised to the power 0, anything raised to the power 0 is 1. Now, if n is greater than m, then we're going to get a negative exponent. And we know if we have a negative exponent, to change it to positive, we find the reciprocal of the value. So if I have a raised to the power -5, is the same as writing 1 over a to the power 5, positive 5. Now, if you have two terms, a times b raised to the power m, it means m affect both a and b. They are all in the parentheses. Same thing applies if it's division. It means the m exponent affect both a and b also. Now, if you have exponent raised to another exponent, then you multiply all the exponents. So I think this is the foundation for this section. So they gave us a few examples. Let's look one example here. These are straightforward. So s divided by y raised to the power 4. The answer will be s to the power 4 divided by y to the power 4. This one also, we have everything raised to the power 4 here. So 3 raised to the power 4. S is 2, so 2 times 4. Y is raised to the power 3, so 3 times 4, and we get this. So I'm going to wait for a few seconds if any question, otherwise I keep going.
Yes, sir. I have question. Exercise 3.4.
Exercise where?
3.4.
3.4, okay.
Yes.
I think I opened the folder already. Let's see. Okay, 3.4.
Yeah, number 2.
Number 2?
Yes.
Okay, so number 2 is given here. They say if C, let's try and zoom it so everybody can see well. Okay, here they say if C equal to 2, 0, 1, negative 4, 6, negative 2, 12, negative 12, 3, and D is given as this. Here you can see that D is multiplied. We call this the scalar multiplied by matrix. So 1, 6, and everything in the matrix, all the values in the matrix, we have to multiply it by 1, 6, and that is the D. Now the question said, are C and D inverse matrices? So remember what we can do to see if this 2 is correct. To find an inverse, or to check if 2 matrices are inverse, I would say the quicker way to do that actually is given here also. You see, if A, inverse of A means A raised to the power negative 1. If I multiply A by A raised to the power negative 1, my answer should be what? Identity matrix. I should get, depend the size. Okay, here the size is 3 by 3. So I should get 3 by 3, but all the values should be 0, by the diagonal will be 1, 1. So you have 2 options of checking this. Since the 2 matrices are given, if you like, you can multiply this matrix, but that's a long process. The best way, again, multiply the, let me show the example. I think I quite remember we have this as, oh no, it's in the textbook. But again, the best way to do this is that 3 by 3 matrix is given, and B is the inverse. What does the product A and B equal to? If I have 2 matrices and they are, one is the inverse of the other one, if I multiply the 2 matrices, I'll get the identity of the matrix. What I mean, I think, let me see, I think the quicker way is to come here. Again, since I can't write on the question, and I found out explaining it is, we have students asking questions, you should write. So I'll try to see if we can get a good solution already given. Yeah, something like this. Actually, this is very quick. So by here is 2 by 2. So you see the question they gave us, they already gave us the first matrix, which is A, and they say the second matrix, if it's the identity of the first matrix, they are asking us. So this is the same question. Is B the inverse of A? Sorry, I'm using the term identity. Identity is the result we're going to get. So for example, if I have matrix A as 1, 2, 1, 1, matrix B as negative 1, 2, 1, negative 2. If I multiply these 2 matrices and they are inverse, I should get identity of it. I don't know if I answer your question. So it's exactly the same. The only thing, the question is 3 by 3. But for example, you see, if I multiply A by B, I should get identity. And if I multiply B by A, my answer should be identity. Here we say that B is the inverse of A, or B is the inverse, we write it A to the power negative 1 means inverse. Why? Because we can see from the solution we get here. Now, if I multiply A with B, and I didn't get this, let's say I get 5 or something somewhere, then A is not the inverse of B. So back to the question again. Let's see if we get. So here, sometimes a question will be given, which I'm trying to explain here. Let's see, you will see that example somewhere. Again, these slides help a lot. Sometimes a question will be given and only one, they will give you only one matrix, and they will say, find the inverse of that matrix. To find, yeah, say if inverse exists for a square matrix A, we find A raised to inverse as follow. So this question, you see, they give you only one matrix and they say you should find the inverse of it. So what do? You use the Gauss-Jordan elimination method. So here, you see, this is 2 by 2, we write it down. Then on the right side, we write the identity of it. Now, if it's 3 by 3, you write the identity matrix also 3 by 3. Then you do the Gauss-Jordan elimination method. Those 3 principles you can interchange 2 rows, or you can multiply non-zero value to 1 row, or multiply hard, and those 3 operations, you can perform them, then you change it to this form. If the left side can be identity, then there's inverse. The inverse will be the right side. So when we do the Gauss-Jordan elimination method, we got this. So the reason I'm trying to explain this is that it depends on the question. The question will give you, find the inverse of a matrix. They give you only one matrix. They say, find the inverse of it. So this is the method you have to use. You use the Gauss-Jordan elimination method by setting the augmented matrix as this. 2 by 2 to your right, you have the identity matrix the same size. Then do the Gauss-Jordan elimination process. Then if you can be able to get the left side as identity, then the right side will be the inverse of the matrix. But in our question, in your question, they give you the matrix A, and they give you another matrix, and they are telling you if the other matrix is the inverse of the first matrix. Okay, if that's the case, multiply the 2 matrices. If your answer is identity, change it the opposite way also. If the answer is identity, then here see we get identity for both answers. So yeah, we say A is the inverse of B, or B also is inverse of A. So that's the solution for that question. Let's go back again. Yeah. So here, for example, first of all, you can multiply 1/6 by everything here. Or what you're doing is that you multiply the 2 matrices here. Multiply C by D. If you get identity matrix result, you have to do it again. Instead of CD, multiply D by C also, just to cross-check and make sure. C times D and D times C should give you identity matrix. Then yeah, we say that C is the inverse of D. So I'll wait for a few seconds if any other question. Okay. Okay, so this is against 0.4. You should know the radicals and rational exponents. And there's some few examples how to solve the problems here. This is one of the rules. The only thing we should know here again is that always a square root or cube root or the symbol here always means the base is 1 over something. So if it's a square root, it's 1 over 2. If it's a cube root, 1 over 3. So again, we can use that to solve the problem. So that's example they gave here also. Again, I keep going, but if you have any question, you can stop me. Or if you have any question in another chapter, I can stop what I'm doing. Then I'll go to your chapter. Yeah, just to make sure everybody got the concept together. So that's chapter 0. And I think chapter 1 should be straightforward. So we don't need to do chapter 1, unless if you have any question with that. Simple equations. But yeah, chapter 1 is very straightforward, simple equations or linear equations and functions. This is kind of like a review from college algebra or a developmental intermediate algebra. So I'm going to skip all the chapter 2, unless any question. Okay. So let's go to chapter 3. I'm skipping chapter 1, so I'll go to chapter 2 now. Again, the book starts from chapter 0, so sometimes I'll call chapter 0 as 1, chapter 1 as 2. Yeah.
Professor, can I know how many questions in the exam?
20 questions. 20? Yeah, for the whole period, 1 hour, 40 minutes. Again, it depends. We will go up to 1 hour, 50 minutes, but not more than 2 hours.
But it will be on Zoom, right?
Yeah, it depends. I posted that it will be on Zoom, but again, it depends on my health issue. So hopefully by Tuesday, Wednesday, maybe to be on class. I'm hoping that I will soon come to the campus Again, I don't want to mention detail about why I cannot come, but the department already know about it. Some few health issues. So I'm hoping I can come Wednesday. So if you don't see, actually, that's what I'm supposed to mention. I didn't even mention that. If you don't see, I post the announcement that most likely we're going to have the midterm on Wednesday on Zoom. But if you don't see no announcement by Wednesday morning, it means we meet in class. We will be in class on Wednesday.
Okay, thank you.
Because the class is supposed to be campus. If I take it to Zoom, maybe because of some 1 or 2 reasons why. So our primary schedule is supposed to be in the campus. I'm hoping, hopefully today will be the last day for the Zoom team. So we can be on campus regularly. Okay, so if no question, I'm stopping here. That's the sections we need to cover.
Wait, so hold on for a second. So is the test online or in person? Because I feel like the last couple of days you've been switching it up. Like 1 minute is there, 1 minute is then. What's the final verdict?
What I said is that the class is a campus class. So the reason why we're having Zoom because of maybe some few other issues, but if you don't see announcement by Tuesday night, Tuesday evening, then it means we are meeting. Actually, I'll post the announcement. Whether we are meeting in class or the Zoom, I'll post an announcement by Tuesday. But I'm looking forward for us to meet in class. And hopefully no more Zoom. Zoom maybe because of 1 or 2 reasons. But again, the goal is to have the class on campus. Okay, so I'm waiting. If no question with this section, then we go to chapter 3. Actually, we went through chapter 3 a lot already. Even we just finished it last week, Wednesday too. But let's go to chapter 3 if any question then. So this is chapter 3 also. Is that chapter 3 now? No, not yet. Oh, this is chapter 3. It's like they skip this. Well, this is a e-book. So, okay, this is it. Okay, so again, chapter 3, we talk about matrices. So you should know addition, subtraction, and how to multiply matrices, and Gauss-Jordan, and also the inverse of square matrix using the matrix equations. So we should know up to this 3.4. Actually, that's where we reach. I said application, we will hold on to that for now, but actually, excuse me, the application problem is the same. What we learned from 3.2 to 3.4, we apply it to solve the application problem. So the main techniques, we already learned it. The only thing, there will be no application problem like a business question whereby you have to use a matrix. But again, it's not that. It's like the simple linear equation or quadratic equation. After we learn the concept finish, we apply it on, for example, the equilibrium market, where we know again, supply and the demand should be equal. So we have a supply equation, we have demand equation. The same thing with matrix. We may have a matrix normally is in the tabular form. We have rows and columns. So a data set will be given in a business organization whereby they arrange the data in a tabular form. So it's kind of the same concept. We can apply it. I have to maybe the cost, the total cost and the revenue, and I want to find the profit. This data is in the form of matrix. All I need to do is I check if the 2 matrices are the same size. If they are the same size, then I'll subtract the total cost of the matrix from the revenue of the matrix, then I'll get my profit. So the application is the same concept. The only thing is that our data is given to us in the form of rows and columns, like a table as matrix. We're doing 2-dimensional rows and columns. Okay, so if no question, then I'm going to stop this recording for review.